This is example 1. It says construct a triangle given that angle A is 35 degrees, side B is 10, and side A is 7. No units on these numbers. They could be feet or inches or whatever. And so our standard layout for constructing a triangle, we start in the bottom left. We call this angle A, and then we work counterclockwise. This is angle B, angle C. And the sides opposite have the same names. A is opposite A, B is opposite B, and C is opposite C. And so given this information, we can construct a triangle using this layout. We know that angle A is 35 degrees. We could use a protractor to measure this if we wanted to be very accurate. We know that side B is 10, so they're giving us the length of this side. We know that this is 10. And then they don't tell us how long side C is, and they don't tell us what angle C is. But they do tell us that side A is 7. And so we have two different options here. A line of length 7 will fit here, but a line of length 7 also fits here. Okay, and again, I could use a ruler and a protractor and measure all of this out and draw two different triangles that has angle A is 35 degrees, side B as 10, and side A could be 7. And so angle C is either this very acute angle or a less acute angle. And the length of side C is either this very short line segment or this very long line segment relatively. And so there's two different options here, and we're not entirely sure which one is correct. In fact, they're both correct. Right? There's two different triangles that we could draw that satisfies this given information. And so there's two answers here. And when we go to solve triangles later, using again the law of sines, we'll run into this where there's two different possibilities. We'll apply the law of sines. We will take the inverse sine of some number, and we're going to get an angle, but we know that when we take the inverse sine of an angle, there should be two answers. And so we will see that in later examples. This is example 2. It says construct a triangle given that angle A is 45 degrees, side B is 10, and A is 5. Again, no units on these numbers. They could be feet or meters or whatever. And so again, we have a standard layout for our triangle where this is angle A, angle B, and angle C. And then the sides opposite these angles are A, B, and C. And so we'll start with angle A. We know that angle A is 45 degrees. So angle A is 45 degrees. The length of side B we know is 10. And we don't know the length of side C, right? So it could be as long or as short as necessary. And we don't know the angle of C. It could be as small or as big as necessary. What we do know, though, is that side A is 5. So the side that comes from this point is 5 long. And if you use a ruler and a protractor to draw this 45-degree angle, with this side being length 10, and then you try to draw a side here that is of length 5, you'll see that a triangle cannot be formed. It's impossible to draw a triangle where the hypotenuse is 10, one of the angles is 45, and the other side is 5. It's impossible. This side is not long enough. And so if we had a line segment here, or like a piece of string that was tied to this point, and we swung it around, you would see that the string in no way can form a triangle. And so this is another case where, given some information about a triangle, in the previous example we had two possible solutions. In this example, there are no possible solutions. There's no triangle that satisfies this information. This is example 3. It says construct a triangle given that angle A is 60 degrees, side B is 6, and side A is 10. Again, no units on these numbers. We're going to follow the standard layout for our triangle. This would be angle A, angle B, and angle C, and then the sides opposite, A, B, and C. And so we'll start with angle A. So we're going to have side C and an angle of 60 degrees. We know that the length of side B, which is this side, is 6. So we can measure this out with a ruler and a protractor if we needed to. And then the length of side A is 10. And so they didn't tell us the length of side C. It can be as long as necessary. We're not sure how long it needs to be yet. But we do know that the length of side A is 10. And so we'll start here, and we'll draw a line that is about 10 long. Okay, now is there more than one option? Well, if this was a string and we could swing it, you would see that the side that is 10 long, this side that is 10 long, only touches side C at one point, and that's this point. And so over here, it doesn't make any sense for side C to be this long in this direction, because if it were, the angle wouldn't be 60 degrees anymore. The angle of angle A is only 60 degrees as long as A and C both go off in these directions, right, to the right and up and to the right. It doesn't make any sense for C to go to the left because the angle would no longer be C. In other words, I could draw a triangle here where the length of this side is 10, but the angle here is no longer 60 degrees, and so that won't satisfy. And so there's only one possible solution for this information. And so we've seen 3 examples. The first example, we had 2 possible solutions. The second example, we saw no possible solutions. In this third example, we see that there's only one possible solution. So when we're solving triangles from given information, and we go to try to solve for the remaining information that we don't know, we must be careful about how many possible solutions there are. There's either 2, 0, or 1. When given some information about a triangle, and then we're asked to solve for the remaining unknown information, we need to first determine how many possible solutions there are, and there's a mathematical way to do this. So remember, there's either no solutions, 1 solution, or 2 solutions. And so to determine how many possible solutions there are, we first need to consider the height of the triangle, or the altitude. And so if we look at the height of the triangle, and we'll call this h, and this triangle is not normally a right triangle, right? So I'm creating 2 right triangles by drawing the altitude h. For the altitude h, the sine of angle A will be equal to the opposite side, which is h, divided by the hypotenuse, which is b. So just for this triangle, the opposite of a is h, the hypotenuse is b. So the sine of a is h over b. And if we solve this for h will be equal to, we multiply both sides by b, h will be equal to b sine a. And so we can determine the value of the height of the triangle as long as we were given an angle A and a length of a side B. Now, I could do the same thing. If they gave me angle B, I could still determine the height of the triangle by using the sine of B is equal to h over A. And so it doesn't matter which angle or side that they give me, I can determine a height of the triangle, right? So there's 3 different heights here. You know, there's this height, where this is supposed to be perpendicular, and there's also this height, where this is also supposed to be perpendicular. So I can draw an altitude from any base of the triangle as long as it's perpendicular to that base, and then goes up to an opposite angle, right? So I can determine any one of those 3 heights, but in general, this is the layout that our triangles will be given in. Most of the problems give us angle A and the length of side B, though that's not always the case. It doesn't matter. We can solve it for any information that was given to us. So if we know the altitude, which we can calculate as long as we were given one of the sides and an angle, we can determine the height. There's 4 different possibilities here. And so we can have, and I'll label these as possibilities A, B, C, and D. Possibility A is that we have a triangle where we were told angle A, we were told the length of side B, we were able to calculate the height of the triangle h by multiplying b times the sine of A, and then we were given a length of side A. And so one of the possibilities that we have is that A will be greater than the height, which we calculate. A is given to us, h we calculate, but A is less than B. Right? This is the first option that we have. A is longer than the height of the triangle, but it's smaller than the side B that was given to us. If that's the case, A has 2 different possible positions. A either falls here, or A can fall here. Okay, and I hope that makes sense to you because A is longer than H. It has to not fall directly on H. If it was shorter than H, it wouldn't touch this opposite side at all. And as long as A is shorter than B, A will fall somewhere between angle A and the right angle formed from H, right? So as long as A is shorter than B, it falls in this area somewhere, and then also over here. And so if A is greater than H, but less than B, then there are two possible solutions. Okay, so if we're given information about a triangle, and we're asked to solve for the missing information, the first thing we need to do is calculate H, determine if A is greater than H, but less than B, and we'll see the other possibilities here in just a second. And that allows us to determine how many possible solutions there are. Then we can carry on and solve for the missing information, knowing that there should be two sets of possible answers as we solve for that missing information. Second possibility that we have, I'll call this possibility B. Again, we have a triangle that has an altitude or a height. We were given angle A and side B. We were also given the length of side A. And again, H can be calculated by B sine of A. And the possibility that we're exploring here is that H is less than B, which is almost always the case. There's a couple of rare instances where H is possibly equal to B, though that wouldn't really be a triangle at that point. But H has to be smaller than the hypotenuse of this right triangle, right? So H is almost always less than B. But the important part is that A is greater than both B and H. If A is greater than B and H, there's only one possibility for A. So it's not possible for A to be over here somewhere, because again that would give us a triangle like this, and the angle A is no longer preserved, right? So angle A switches to its complement. So if A is longer than B, this is not a possible solution to the triangle here. So if A is longer than B and greater than H, there's only one possible solution. Okay, a third possibility is that we have a triangle with angle A, and we were given side B. We were also given side A, and when you draw the height of this triangle, you discover that the height is equal to A. And so again, the height is B sine A. If the height is equal to A, you have a right triangle. And so there's only one possible solution. We have a right triangle, that's the only solution. So this would be one possible solution. So you calculate H. If H is equal to A, you'll see that there's only one possible solution. Okay, and the fourth possibility is that we have a triangle. Rather, I should say that we're given angle A, we're given the length of side B, and we draw the height, which is perpendicular, and we're trying to determine where side A is. If we find that A is less than H, if A is smaller than the height, right, where this is the height, if A is smaller than the height, there's no possible solutions because a triangle cannot be formed. So if A is less than H, no solutions. So these are our four possibilities. You're given some information about a triangle. You're asked to solve for the missing information. Start by calculating H using the length of the side that was given to you times the sine of the angle that was given to you. And then check to see if A is greater than H but less than B. If it is, you know you'll have two possible solutions to that triangle. If A is greater than H and B, there's only one possible solution. If H is equal to A, there's only one possible solution, a right triangle. And if A is less than H, there's no possible solution. So a triangle cannot be formed from that given information. This is example 4. It says if angle A equals 26 degrees, side A is 25 centimeters, and side B is 41 centimeters, solve the triangle. And so the first thing we need to do is determine how many possible solutions there will be. So remember that H will be equal to B sine A. And so H will be equal to 41 centimeters times the sine of angle A, which is 26 degrees. And so we'll use our calculator to determine that. 41 times the sine of 26, and we get 17.97. H is 17.97. And so if we sketch out the triangle, or at least as much of the triangle as we know about so far, we will see that angle A is 26 degrees, so it's a fairly small angle. The height of the triangle is 17.97, and they tell us that side B, which is this side, is 41 centimeters, and that side A is 25. And so side A is 25 centimeters. That's bigger than H, but it's smaller than B. And so H is smaller than A, and A is smaller than B. So in other words, H is 17.97. That is smaller than 25, and that is smaller than 41. This is case A, in which we have two possible solutions. And you can see that from the sketch, I hope, that if side A is 25 centimeters, we have a possible solution here, and we have a possible solution here. So either this is side A or this is side A. And this is angle A. This will be angle B. So angle B is either this obtuse angle, or angle B is this acute angle. Side B is 41, and side C is either this small side here from between A and B, or this long side between A and this B. So again, there's two possible triangles. There's this triangle, which is an obtuse triangle, has this obtuse angle, or there's this possibility where this will be an acute angle. I assume that this angle is probably acute, but I don't really know for sure yet. And so we know that we're going to have two solutions. And so we need to use the law of sines to solve this triangle. We know that A over sine A is equal to B over sine B is equal to C over sine C. That's the law of sines. And so we know angle A, we know side A, and we were given side B. And so we're going to use A over sine A is equal to B over sine B. Right? We know A, we know angle A, we know side B. We're looking for angle B. And so we will have that A over sine A is equal to B over sine B. A we know is 25 centimeters. Angle A is 26 degrees. That is equal to B, which is 41 centimeters, divided by sine B, which is the angle we are looking for. And so we multiply both sides by sine B, multiply both sides by sine 26, and divide both sides by 25 centimeters. And we will get that sine B is equal to 41 centimeters times the sine of 26 degrees divided by 25 centimeters. So we'll use our calculator to work this out. We have 41 times the sine of 26, close parentheses, divided by 25. And we get that sine B is equal to 0.7189. 0.7189. And so now we can take the inverse sine of both sides. And so B equals the inverse sine of 0.7189. And so we'll take the inverse sine of 0.7189, close parentheses, equals, you get 45.96 degrees. B is 45.96 degrees. And so if we look at this angle in the coordinate plane, we have an angle that is 45.96 degrees. But remember, anytime we use the inverse trig functions, our calculator gives us one answer, but there's actually two answers. And so sine of any angle between 0 and 180 is going to be a positive number. And so there's another angle over here from standard position that if we take the sine of this angle, we also get 0.7189. And so we need to determine that angle. We know that the reference angle closest to the x-axis is still 45.96 degrees. And so if we take 180 minus this 45.96, we will get the other possible answer. So B is either 45.96 or B could also be 180 minus 45.96. And so we'll type that in. 180 minus 45.96. And we get 134.04. So B is either 45.96 degrees or it's 134.04 degrees. And I can check these answers to make sure. So let me check them for you. The sine of 45.96 is 0.7189, and the sine of 134.04 is also 0.7189. And so when I took the inverse sine, I only got this 45.96 answer. But there's actually two different angles that when I take the sine of that angle gives me 0.7189. And so I had to determine the second possible answer. And so angle B is either this acute angle, 45.96 degrees, or it's this obtuse angle, 134.04 degrees. So there's two different possible solutions here. We have an angle that looks like this, where again this is 26 degrees, this angle. This angle B is the obtuse 134.04, and side A is 25 centimeters, and side B is 41 centimeters. This is one of the possible solutions. I still don't know angle C yet or side C. The other possible solution is this bigger triangle, like this. And again, this is still the 26 degrees. This is still 41 centimeters. This is still 25 centimeters. But here we have an angle of 45.96. So there's two different possible solutions here. And again, I still haven't found angle C or side C in either one of these triangles. And so there's two different answers for angle C and side C as well. One of the answers is that the angle C is 180 minus 26 minus 134.04, because they all three have to add up to 180. And so we have 180 minus 26 minus 134.04, and we get 19.96. So this very small angle here is 19.96. Or we have 180 minus 26 minus 45.96. And so this angle is obtuse at 108.04. The last step of the problem is to find side C. And since we know angle A and side A, we should use A over sine A is equal to C over sine C. And so that's what I'll do. And again, we'll have to do this twice because there's two different answers here. So A is 25 centimeters. Divided by the sine of A, which is sine 26 degrees. That will be equal to C, which is the side I don't know yet, divided by the sine of angle C, which is 108.04. Multiply both sides by sine of 108.4, and C will be equal to 25 centimeters times the sine of 108.04 divided by the sine of 26 degrees. So we'll type this into the calculator. We have 25 times the sine of 108.04, close parentheses, divided by the sine of 26, close parentheses. You get 54.23. So in this triangle, where angle C is an acute angle and angle B is obtuse, then side C, it's this triangle, right, where angle C we think is 108.04. In this triangle, where angle C is 108.04 and angle B is 45.96, we get a length of side C of 54.23 degrees. And for this triangle, we'll do the same procedure here. A is definitely 25 centimeters, divided by the sine of angle A, which is definitely 26 because that's information that was given to us, will be equal to, in this case, angle C, instead of being 108.04, is 19.96. So we're looking for side C, and in this case, angle C is 19.96. Same thing, we'll multiply both sides by sine of 19.96, and C will be equal to 25 centimeters times the sine of 19.96 divided by the sine of 26 degrees. And so we'll find side C. Type that into the calculator. 25 times the sine of 19.96, close parentheses, divided by the sine of 26, close parentheses, equals 19.47 centimeters. And so in this triangle, you can see that the side C is much shorter, 19.47. Okay. And so just to recap, because A was greater than H, we calculated H from B times sine A. Because A was greater than H, but A was less than B, that means we had two possible triangles, and these are the two possible solutions that we've come up with. This is example 5. It says if angle A is 62 degrees, side A is 415 meters, and side B is 855 meters, solve the triangle. And so again, the first thing we need to do is calculate the height of the triangle. The height of the triangle will be B sine A. And so the height is side B, which is 855 meters, times the sine of angle A, which is 62 degrees. And so H will be 855 times the sine of 62, which is 754.9 meters. So it's helpful to sketch the triangle so that we can imagine this. Angle A is 62 degrees, so sort of a large angle. And side B, which is this side, is 855 meters, and H is 754.9 meters. And so A is 415 meters, H is 754.9. That means that A is less than H. A is less than H. So A is 415 meters. And that is less than H, which is 754.9 meters. What that means is that A is not long enough to reach this side. That means that there's no solution. This is case, let me look real quick so I can remember. This is case D. When A is less than H, there is no possible solution. And so for good measure, let's see what happens if we try to solve the triangle using the law of sines. And so remember that A over sine A is equal to B over sine B, and that's equal to C over sine C. And so what will happen? Well, we know A's angle and side. We know B's side. Let's find B's angle. And so we will use A over sine A is equal to B over sine B. Plug in the numbers we know. A is 415. Angle A is 62. Side B is 855 meters. And angle B is what we are looking for. So we'll multiply both sides by sine B, multiply both sides by sine 62, and divide both sides by 415. When we do that, we will get sine B is equal to 855 meters times the sine of 62 degrees divided by 415 meters. Let's work this out first, and then we'll take the inverse sine. Sine B will be equal to, we have 855 times the sine of 62, close parentheses, divided by 415, and we get 1.819. So we'll take the inverse sine of both sides. B is going to be the inverse sine of 1.819. And when you type this into your calculator, the inverse sine of 1.819, and you press equals, you get an error. B is equal to, we get an error. Not possible. Not possible. And so that confirms our suspicion that there was no solution to this triangle. A is simply not long enough. The angle for B is not possible. There is no angle that we can make angle B, which is actually this angle down here. This is angle B. there's no angle that angle B could be to make this side reach this side if this angle is 62 degrees and this side is 855 meters long.